Good afternoon. We are Group 5 Class 4, and this is our class management system project. We developed this project with user experience in mind. We wanted to enhance the usability and functionality of this project while keeping the program foolproof as we would expect of a commercial product. We also kept things simple and modular, applying what we learned in the Programming Fundamentals module. So this is what we did differently to enhance the user experience. We made all our functions and their functionalities fully case insensitive and also space insensitive. We also implemented multifunctionality for insert, query, and update functions. For the insert function, you allow the user to just enter the student ID and let the program prompt for other variables, or enter all the variables at once. We also allow the user to enter some variables and let the program prompt for missing variables. For our query function, you allow the user to query for ID, name, degree, and mark. Name and degree searches search for partial matches too, and the user is able to search by a range of marks instead of an exact mark. For the update function, we allow the user to update multiple variables at once. This is our program flow. When the program starts, the user authentication system requires the user to log in first, after which the user enters the main loop where he or she can input commands, and the program will carry out the necessary functionalities after. This main loop is repeated until the user exits the program using an exit command. This is how our files are organized. Our main loop, functions, and authentication modules are in separate files. Our database files are in a separate directory. And all of this is managed by the header file. This is our data structure design. We have a student structure, which represents a row in the table. One student struct has one student record, which contains student ID, name, degree, and mark. We have a CMS structure, which acts as the bigger database table, which contains an array of student structs, metadata like file name, database name, authors, and operational states, which indicates whether the database table is open or modified. In the CMS structure, there are also variables that store backups for the undo functionality. These are our features implemented. We implemented all the basic functions and added an exit function to allow the user to safely exit the program. We also implement all the enhancement features, which is the show summary and show all sort by ID or mark. We also implemented multiple bonus features, which includes case and space insensitivity, our user authentication system, a help command, which acts like the manual function in the Linux command line. We also implemented data backup and an undo functionality, in addition to the multifunctionalities of insert, query, and update. Now we'll move on to the demonstration.
Now, let's run through the CMS together. As we go along, feel free to imagine yourself in the keyboard typing the commands with me. First, we need to start the CMS. We run the helper script that compiles the code and runs the executable. You should see the CMS welcome screen. Before entering the main CMS functions, the system requires login. Similar to an actual DBMS, as you can see, the user is allowed a maximum of 3 attempts before being locked out. Let's purposely fail once just to see what happens. The CMS responds with an error and a warning that only 2 attempts remain. Now, enter the correct credentials. This time, we get a confirmation message.
Next, let's load our demo dataset with the open function. The CMS tells us that demo.txt has 14 records. You will also see a warning section where a few problematic rows have been skipped. These rows with invalid values in one or more fields. On screen, we will show you which rows were skipped, so you will know exactly what needs attention later. As you can see, row 5 is invalid mark and row 9 is invalid ID format. The valid records are loaded. The invalid ones are safely ignored for this session. Now, let's explore the data. So now you should be able to see that all student records are printed out in a table. IDs, name, programs, and marks. To make things more interesting, let us sort them. Now, the students are listed from highest to lowest. Take a moment to scan the bottom of the list. You will notice that there is a small group of weaker performers at the end. There appears to be 3 students below 75.0. We can check this more precisely with a query in a moment.
Our query function works on all columns. We can query by ID, name, program, or mark. For now, let us zoom in on mark. The CMS returns all students who scored below 75. These are our current underperforming students. If you already knew their IDs, you could have gone straight to a multiple ID query. Let's try that next. Notice that we have an extra 4 in the last ID on purpose. The CMS detects that 230-10144 is not a valid identifier in the dataset. It ignores the invalid ID and returns the 2 students that do exist. To fix that, let's run the proper command. This time, we get all 3 of our low-scoring students, and they are David, Frank, and Noah. To understand the group better, we can look at an overview. The CMS shows summary statistics, including the class average. Here we see that the average mark is 83.16. Keep that number in mind. We'll use it shortly for a new student.
Like a normal DBMS, our CMS allows insertion of new rows. Imagine a new student walking in, Bradley, who has just joined the course. We want to add him. First, let's demonstrate what happens if we try to insert a new record with an ID that already exists. The CMS checks the primary key, realizes that 2301015 already exists, and rejects the operation with a clear error. Cannot insert duplicate ID. Good. The system is protecting our data from duplicates. Now, let us use a fresh, unused ID for Bradley. This time, the CMS responds with a success message. The new record is inserted. To confirm, you should see Bradley's new record with marks
83.2.
Sometime later, Bradley comes back. Prof, I just did the test and got 90. Can you update my score? Our CMS supports updates, but only on existing records. Let us demonstrate both a failing and a successful case. First, let's try to update on a non-existing ID. The CMS looks for ID 2309999, does not find it, and returns an error indicating that no such record exists. As expected, no changes are made. Now, let's do the correct update for Bradley. We verify by querying his ID again. You should now see that his marks has been updated from
83.2 to 90.
now. Suppose Bradley also changes program. Maybe he transfers from applied AI to speech therapy. And again, we confirm. Our CMS also has an undo feature, which can roll back data, changing operations such as insert, update, and delete. Since we have just performed several updates on Bradley, let's try undoing them. This reverses the most recent operation, which was the program update. To confirm, run query. Now Bradley's program should have reverted to apply AI, while his marks is still at 90. Let's undo again. This time, the CMS rolls back to the previous update, which was the mark change. Now you should see Bradley back with his original mark of
83.2.
and program applied AI. This illustrates that we can undo more than once, stepping backward through recent insert, update, and delete operations.
Next, let us demonstrate deletion. First, we try to delete a non-existent identifier. The CMS checks and reports that no such record exists, so nothing is removed. Now, we'll delete the Bradley record that we inserted earlier. The CMS asks for confirmation to avoid accidental data loss. You'll see a confirmation. The system responds with a success message and Bradley is now deleted. We also support a more guided insert function, where you only provide the ID initially and the CMS prompts for the remaining data fields interactively. This time, because only the ID was provided, the CMS prompts you to enter the name, program, and mark. Once all fields are entered, the CMS confirms the insertion. You can verify the insertion with the following command.
So far, all changes have only been in memory. To make them permanent, we use the save function. The CMS writes the updated data back into the underlying text file and returns a success message. To illustrate this, we show the contents of updated.txt file on screen, where you can see that the newly inserted and deleted records are reflected appropriately in the file. If at any point you forget the commands, their syntax, or the available options, we have a help function. The CMS prints a list of commands such as open, show all, show summary, query, insert, update, undo, delete, save, help, and exit, along with a short description and basic usage pattern for each.
Once you're done with all your operations, you can cleanly exit the system. The CMS closes the session, saves any final state if required, and terminates gracefully. And that concludes our interactive run-through of the CMS system. Thank you.